Hey everyone, I'm Sahiti, and today I'm going to present my course project, which is live video streaming application, and I do consent to release my video presentation on YouTube. So moving on to agenda. So today we're going to discuss what are the objectives of this project and what is the design and implementation of my server and client code, and how the application is deployed on the Android phones, and a demo followed by evaluating the performance and challenges and future work that I've faced through this project. So the objectives are to create a user-friendly platform that can transmit live video from mobile device to a remote server in real time. So it needs to facilitate seamless communication through live video streaming. So it involves developing a reliable server-side infrastructure and a cutting-edge application that can leverage this power of live video streaming and enable users to connect, share, and interact in real time. So moving on to the design and implementation of my application. So how does server side work is basically UDP socket is used for this application. So why UDP socket is used is UDP is unreliable compared to TCP, but still it provides the speed that is not provided by TCP. And since this live video streaming is not confidential and it is not like messages or emails that are that need to be very reliable, UDP can be used in this application. And at the same time, any other reliable transfer protocols needed can be implemented on the application layer itself. So yeah, that's the reason UDP socket is used to guarantee the speed of video streaming. So a UDP socket is created and it is binded to a specific IP address and port that the server is running. And this socket is used to receive data from the client, which is video frames in our project. So the video streamed by the client is sent as image frames, which is in the form of bytes. And this data, which is received as bytes, is unpickled and decoded as image frames. So the images that are captured by client are basically sent as bytes to server, and the server unpickles this byte and decodes it as image frame so that it can be displayed on the server end. And when the client closes the connection, this server also ends, and we can see the performance metrics that are computed, and the socket is closed. So through this implementation, I first started with developing a web-based GUI before moving on to the Android application. So what GUI is so basically it uses a library called Tinctor. So it provides a basic GUI, and I designed it in such a way that it has two buttons. One is start stream and stop stream. And to capture the stream, which is the video, OpenCV is basically a library that has many functions for image and video processing. So video capture can be used to capture video from the device camera. When the start stream button is pressed, the UDP socket is initialized and the socket send buffer size is also initialized. And as the video frames are being captured, each frame is encoded as a JPEG image using OpenCV's IMEncode function. And this is pickled and sent as bytes to server, as we discussed previously. So this all is done when the start stream button is pressed, and when the stop stream button is pressed, the server stops receiving the signal from client and the stream is closed. So this is how GUI works. So similar to how it works, Android application-based client also works in similar way, but instead of Tinctor library, a Kiwi framework is used. Kiwi framework is basically a Python library that provides some Android-based functions. So if we use Kiwi, it's easier to deploy this code on an Android mobile device. because the GUI is more user friendly on an Android device. So how the GUI is designed is it has a vertical box type layout, and the widgets used are a text input to enter the server's IP address to connect to that particular server, and an image to display the stream video, and camera widget to capture the video frame from device camera. Similar to the web GUI, the start stream and stop stream. And when the start stream is clicked, the image frames are sent as bytes. When the stop stream is clicked, the stream stops. So the main difference is using Kiwi image, basically how the framework or GUI is designed, and how the frames are being updated in both the cases. But other than that, the functions are pretty similar. So a new design is also implemented. So the implemented new design is a compression technique to reduce the network usage by reducing the amount of data that needs to be transmitted over network. To do this, the zlib library is used. So what zlib library does is it allows data compression while communication is handled between server and client. So zlib.compress compresses the data before sending it to the server, and the bytes whatever are compressed are decompressed on the server side using zlib.decompress, and these are again decoded to display as image frames. So this is used to reduce the latency and just reduce the network usage while transmitting data over the network. So one main thing that needs to be discussed is how these codes are transformed into an Android application. So to deploy this client code in an Android device, an APK file needs to be installed on the mobile device. So Bulldozer is a tool that works with Kiwi to develop standalone packages that can be deployed on an Android device. So once we initialize this Bulldozer on the system, a bulldozer.spec file is created, which is basically a configuration file on how this application needs to be run. So it includes details like permissions, requirements, and dependencies that the app needs. So to build the Android package, Bulldozer Android debug command is used. And once the APK file is ready, it can be installed on the phone. So ADB is something that is used to debug the application from a connected computer, which I'll be showing in the demo further. So to do this, we have to enable developer mode on the phone, and USB debugging needs to be enabled on the mobile device. And then we can seamlessly communicate between the computer and the phone once the ADB is enabled and the device is connected to the computer. All right, so moving on to the demo. I'll just quickly off my video because the video needs to be accessed by the applications. All right, so first I'm going to show how the web GUI server and client works. So I'm running the server code of the web GUI based implementation. And now it says that the server is listening on an IP address on a port. And now I'm connecting the client on the same IP address. Now we can see that the GUI is displayed. So now we can click start stream, and we can see that my video is being transmitted to the video server. The image client is the client, whereas the video server is the server. So my device has only front camera, that's why it's showing my own video. But if I actually run this on an device that has a back camera, we can always access that. So now I'm stopping the stream and the stream ends. So yeah, that's how the web-based server and client works. Now I'll show how the Android application works. First thing, as I discussed, I connected my device using ADB to the system. So if I see ADB devices, we can see that my phone is connected. So when this is done, I can actually run the command screen copy, SCRCPY, to display my phone on the on my system. So now I see that this is my application that's on my phone. So now I'm going to show how I can. So one way to install the app is, as I said, you can download the APK file. So as we can see, my APK file is here inside the Kiwi client. And this bulldozer.spec file has all the requirements of my application. And this main.py file has my client code that needs to run on the application. So this is the built APK file, and this can be downloaded and installed on the phone. The other way to actually install via the connected computer is using the command adb install apk. So once I run this command, we can see the app being installed on my phone. So I'm running this command and we can see that the app will be installed. So yeah, we can see a dot, a green dot that shows that the app is being installed. So yeah, now the app is installed. Now we can run this app by connecting to the server. So now let me connect the server. So I'm running the compressed new algorithm server file, but we can always run the no compression file and use the no compression client in the main.py file and build an APK file. I'm just using the new design server and client for the demo. So yeah, I run the server compression py file. It says that the server is listening on 10.0.0.155. Now I'm opening the app and I'm entering the server IP address 155. So that's the server IP address. Now I'm starting the stream and we can see the stream to be seen neatly on my system. Yeah, now if I play this video, this can also be seen on the stream. It does have a little bit of latency, but it can be fixed with more design algorithms. But yeah, it does work in a good way. So yeah, now I'm clicking the stop stream on my phone and the stream is now stopped. Yeah, and now the stream is stopped. So yeah, that's basically the demo of my application. Now moving on to the presentation. Yeah, so I'm going to evaluate the performance now. So without compression, the server side and client side results can be seen. There is a latency of 0.00058 on the server side and 0.0039 on the client side, and 8,223 bytes are sent and received. Whereas with compression, the latency is slightly reduced and the received data at server is 5,135 for 7,493 bytes sent at the client. So that's a great reduction in the network usage because of the compression performed in the algorithm. So that's how the performance can be evaluated. We can use more metrics to understand how many frames are transmitted and everything. But my main performance metrics used are latency and the network usage. So discussing the challenges and the future work, the main challenges that I encountered was while deploying the Android application and debugging the application to resolve the issues of compatibilities and versions of various libraries used. So yeah, it did take a lot of time because building the Android application itself will take about 2 hours or 3 hours. And then debugging it is a time-consuming process. So yeah, that was a main challenge. And more algorithms like adaptive bitrate streaming and dynamic frame rate adjustment can be done along with data compression methods to reduce video streaming latency and increase the quality of the video and also reducing the network usage. And more GUI features can be developed to enhance the live video streaming experience for the users. Yeah, so that's basically the challenges I encountered and the future work I'm planning on. So that's all about my project. Thank you for listening.